If you Google the 1999 Mars lander, you'll read all about the mistake that cost us $125 billion in years worth of scientific data and could have been avoided with a little simple unit analysis. Today's lesson is dimensional or unit analysis, aka are you smarter than most of NASA and Lockheed Martin Engineering Corporation? Unit analysis is here to tell us two things. Number one, what units will my answer be in? And number two, is this formula correct? Both are steps on the way to finding the right answer in any physics problem, anywhere, ever. If you don't know what the answer will be in, chances are the answer you're getting is not correct. If you know the answers are supposed to be kilometers and the answer you're getting is 7.5 billion, then check your math, unless you were trying to get from Earth to Pluto, in which case 7.5 billion kilometers sounds about right. Second question, is this formula correct? Will tell you. The example we did in class today is momentum. Momentum, as we said, means how hard something is to stop. How hard something is to stop depends on how heavy it is, its mass, and how fast it's going, and the direction it's going in. Put together, you get velocity. So here's our formula. Momentum equals mass times velocity. Yes, I know. Momentum is written with a P. Don't blame me. I didn't invent it. It's just that M was already taken from mass and we were out of the letters. Just be grateful it isn't a Q. Momentum, it's P. Just go with it. Bad enough that it's P, what units is it measured in? We know that mass is measured in kilograms and velocity is measured not in miles per hour but in meters per second. What about momentum? Unit analysis says take each letter in the formula, replace it with the units, and do the math. Multiply, divide. In this case, multiply. So let's take it away. Mass is measured in kilograms, so take the M away, replace it with kilograms. Velocity is measured in meters per second, so where we have velocity, put in meters per second. There they are. Now multiply. Kilograms times meters per second. That means momentum is measured in kilogram meters per second. Really? Really, it doesn't get any prettier. This is it. Metric units of momentum are kilogram meters per second of hard to stop. Another interesting example is volume. In chemistry, you measured volume in liters, but not in physics. Why not? Check the unit analysis. Standard formula for volume of anything is length times width times height, at least if you're measuring with the appropriate angles. Length, width, both measured in meters. Height, also measured in meters. What does that make the metric units of volume? Not liters, meters cubed. This is a ridiculously big unit. It's useful only for giant things like airspace, but it's the only way to make the units work. So in physics, if we're measuring the volume of anything that will fit on a tabletop, we are expecting a very, very small number of less than 1 meter cubed, usually a lot less than 1 meter cubed. Later this semester, we'll study the laws of motion. The laws of motion tell us where we will get to based on how fast we're going, which direction we're going in, whether or not our foot is flooring it onto the gas pedal, and how long we've been flooring it or slamming on the brakes. You can solve these problems graphically using calculus or using the long algebra formulas you've derived in class. So here you are with your nice long algebra formula. You think you've remembered it correctly. You're pretty sure you remembered it correctly. Best check before you bust out all of that math. So here we go. Your final velocity supposedly equals your initial velocity, your original velocity, squared, plus 2 times your acceleration, times your displacement, how far you are from where you started. Velocity is measured in meters per second. So let's put those meters per second in there and square them. See this slashy thing? This slashy thing is bad news. Don't use the slashy thing anymore. You'll see why in a minute. All right, next. Next comes the 2. 2 doesn't have any units, so take out the 2 and replace it with, nothing, it has no units, it's beautiful, it's a 2, life is good. A is for acceleration. The units of acceleration, according to your great and noble physics packet, are meters per second squared. Who knew? Meters per second squared, there they go. D stands for displacement, aka your position relative to where you started. Well, that's not bad. That's measured in meters. This is why you don't use the slashy thingy. Here we can clearly see the way the fractions multiply. Top times top over bottom times bottom. This is meters squared per second squared. See that little invisible 1 right under the M? So we have to conclude our velocity, our final velocity, the one we're looking for, has units of meters squared per second squared. That's the first term, plus more meters squared per second squared. This is not what we were expecting. The units of velocity should be meters per second. Two terms? Okay, we can do terms, but they should be velocity equals meters per second plus more meters per second. And they give us a nice big package of meters per second to be our velocity. This equation is wrong. It has to be wrong. There's no question. The units are wrong. They don't match up. We were expecting meters per second. We got applesauce. As far as unit analysis is concerned, the problem stops here. The formula is wrong. Don't go on. Go back and check your formula. Now, if you happen to be studying the laws of motion, you can look at the formula that is clearly wrong by unit analysis, and you can, if you're interested, take it one step further. If velocity is measured in meters per squared per second squared, could it possibly be velocity squared? Could putting a squared on the left-hand side fix your problem and turn a wrong formula into a right formula? Hey, if you look it up in your textbook, you'll find that it does. Just by looking at the units, you were able not only but fix it, and fix it without using your knowledge. I really wanted a formula that said velocity equals it's into meters per second. Squared per second squared into meters per second. Get rid of the squared. Maybe square root? And sure enough, if you want a positive velocity, putting a square root in that formula will definitely give you the right answer. Unit analysis. What's not to like?